Welcome to ScaleUp University. Welcome to the course on building applications with AI agents. So now, this is the lecture 2 of module 1. And in this lecture, we will discuss what are autonomous agents. So basically in this lecture, we will be understanding the true meaning of autonomous agents. Because see, there is a very big misconception or the myth wherein a very large uh, a group of people, you will find that okay, they are misusing the term agent. Like there's a misconception that okay, any chatbot is an agent, any large language model wrapped with tools is an agent, any automation pipeline is an agent. But unfortunately, all these are wrong. These are not agents. And that is what this lecture is about. This lecture will give you an exact idea and clarity and the definition of autonomous agents. Like what exactly is the meaning of autonomous agent? That is what we will discuss in this lecture. So, precise definition of an autonomous agent and what it is not, that also we'll discuss. That is the main crux of this lecture. What are autonomous agents? If we look at important topics that we will cover in this lecture, so we'll start by discussing formal definition of an AI agent. Then we will discuss agents as software acting on behalf of users or systems. Then we'll discuss what is autonomy, like what it really means. Then we'll discuss decision making without step-by-step instructions. So the very interesting thing about agents is that they will decide on their own. Like you don't have to give step-by-step instructions. And agents, they can act under uncertainty. So acting under uncertainty. Then we'll discuss goal-driven behavior, interaction with environments, interaction with humans versus interaction with systems. Then we'll discuss multi-step reasoning and execution. Then we'll discuss independence versus supervision. And finally, we will conclude this lecture by discussing common misconceptions about agents. So all these topics we will cover in this lecture itself, one by one. So this lecture is the module 1, Introduction to Agents, lecture number 2, what are autonomous agents? And the first topic is formal definition of an AI agent. So this is a very important discussion we are making. Like what is the formal definition of an agent, AI agent? So an AI agent is basically a software entity. So it is also a piece of code because what is a software? Software is a piece of code or a collection of programs. So an AI agent is a software entity which has some special capabilities like it can perceive its environment, it can make decisions, and it can take actions autonomously without human intervention to achieve specific or specified goals. So if we go deep, so agent is a software entity. So agent exists as a computational system. AI agent, it can perceive, means it can sense the environment, the outside world. It can receive inputs like the data, signals, messages. And based on the input and the based on the goal it want to achieve, it decides, it plans. Agents can plan. It decides set of actions to be performed. So it selects actions based on reasoning or policy. Then whatever action plan it has made, whatever actions it has decided, it will act on it. It will execute those actions that affect the environment. Because when it will execute the actions, the environment will get affected, then reflect it will reflect, and it can adapt its plan. All that is there. Now here two more very important thing, autonomously, like the action will be autonomous. It means that without human intervention, without step by step human control. So the this is very big thing about AI agents. AI agents on their own, they will make the plan, they will decide what actions to be performed, and on their own they will act, and on their own they will adapt, they will re-strategize. All that they will do on their own. So that is the autonomous. without human intervention. And here goals also plays a very important role, because the agents, AI agents, they're aligned in achieving goals. So they operate towards specific objectives, not just responses. So now I think you got a very good understanding that, okay, when I talk about AI agent, that AI agent has to be a software entity. It should have the capability of perception, planning, that is deciding the actions, then executing, and then reflecting. Okay, what, because when it will execute the actions, environment will get affected and it will evaluate the outcome, and based on that adapt the strategy, like make changes in the plan, and then once again keep on doing the same process, perception, planning, and all that. And here two very important things are there. All this needs to be done autonomously without human intervention, and all this needs to be done to achieve a goal oriented. So AI agent is always goal oriented. So this definition already distinguishes agents from traditional programs, highlighting the shift from passive execution to active goal pursuit. Because the traditional programs, traditional softwares, they are just about execution. Like you give it step by step instructions and they will take care of the execution. That's it. But here, AI agent, their objective is to achieve the goal. They are goal driven and autonomous. They will do all the things. They will plan. They will act on their own with the objective of achieving the goal. Okay, now we'll discuss agents as software acting on behalf of users or systems. Okay, so basically, agents, they are like independent entities, autonomous, so they can represent. So agents do not exist for themselves, they exist to represent intent, fulfill objectives, and coordinate tasks. So agents can act on behalf of users also. So what it means, I'll tell you. Then I'll give you more understanding about intent, objectives, and coordinate tasks. So on behalf of users, so agents can basically replace humans in such a way that instead of a human personal assistant, we can have an AI agent personal assistant, customer support agents, research assistants. All this can be done by AI agents. So the idea here is they will interpret intent. These AI agents, they will interpret the intent, the input they will receive. Here the intent is the goal, and they will decide the action. They will make the action. They will plan that, okay, to achieve this goal, this needs to be done, and they will execute the task. So it's very clear that human operations done by the human, we can replace it with the AI agent, wherein the AI agent can interpret the intent, like the goal we want to accomplish. It can make a plan. It can decide the set of actions to be performed, and it can execute those tasks. And similarly, agents can act on behalf of systems, wherein AI agents, what they can do is we can have monitoring agents which can constantly keep an eye on the system. We can have optimization agents whose goal is to optimize, and we can have coordination agents which will basically help in establishing coordination among a network or a collection of systems. So here, what the agent will be doing is uh, it will basically definitely it will observe the system state, and based on that it will adjust behavior, and it will ensure that the performance is maintained. It is making sense now. So the idea is that if we talk about agents, they operate within a context to achieve goals for their principles, whether human or system. So the idea is that AI agents, we can use it on, they can act on behalf of users, or they can act on behalf of systems. So both possibilities are there. And the main goal of agents, AI agents, is to achieve goal. When it is acting on behalf of user, the set of goals will be different, wherein it will be interpreting the intent of the user. And when it is acting on behalf of systems, the set of goals to be accomplished will be totally different. It will be more of like observing the system state, monitoring the system, and figuring it out whether the system is drifting away from the optimal performance. And if it is drifting away from the optimal performance, it will suggest some changes, and not just suggest, it will perform, it will adjust the behavior of the system so that it always maintain the optimal performance. So that is acting on behalf of systems. Okay, now we'll look into the next topic of this lecture, that is autonomy, what it really means. Yeah, so see that though we already know. If we talk about autonomy, it means freedom, independence, like on its own, no human interference. So freedom in action selection and not freedom from goals. This is very important. This is very important. See, AI agents, they cannot decide the goal. Autonomy is not freedom from goals. Goals, though, it will be decided by the user or the system. Autonomy is freedom in action. So AI agent has the freedom of choosing the plan. Okay, this goal needs to be achieved. AI agents can make a plan. They can execute task to achieve that goal. So autonomy is the freedom in action selection and not freedom from goals. So the agent choose how to act. The agent decides when to act, and agent adapts based on outcomes. So the key idea is, if we talk about autonomy, it's about self-directed decision making towards a defined objective. So objective is already defined, and agent will be on its own. It will be acting. It will be taking decisions to achieve that defined objective. And what autonomy does not mean is, it does not mean no constraints, rules, or oversight. So this is very important. With AI agents, we define constraints, we define rules, we define oversight also, so that agent can't do something very like harmful for the user. Like let us suppose, if you give agent full freedom, and if agent can access your account, then it can just wipe out all the balance. It can do that. So if we set constraint that okay, agent cannot withdraw or do a transaction of more than like $1,000, for example. So this constraint is, we call it guardrails. So guardrails are very important. The constraints we have to apply. So autonomy does not mean that okay, agent is free, it can do whatever it wants. Agent is subject to constraints. Agent is subject to rules, and agent is subject to oversight. Humans are always watching the behavior, the actions of agent. So transparency is there. Autonomy does not mean no alignment with the goal. Agents can never be free from the goal, and agents can never be free from human involvement. For an AI agent, human involvement will always be there, and alignment with the goal will always be there. So autonomy does not mean freedom from goal. Autonomy does not mean freedom from human involvement. And operate, like autonomy does not mean operate without guardrails or monitoring. So it's very clear that okay, if I talk about AI agent, it is autonomous. Autonomous meaning to say that for a particular objective, the goal to be achieved, it can make the plan, action plan, it can perform the actions, and based on the outcomes, it can reflect, it will evaluate the output, it will adapt. That agents can do. But autonomous agents, they are subject to constraints, rules, oversight, monitoring, guardrails. They are always uh, sticked with goal. They have to be aligned with the goal, and they cannot be free from humans. Human involvement will always be there. So the idea is that an autonomous agent, they operates within established boundaries. They are goal aligned, and they can be monitored, corrected, or even stopped. So very important discussion we made. So the moral is that autonomy is not equal to anarchy. Autonomy here, it is guided and constrained freedom. So autonomous agents, they enjoy freedom in action selection. That's it. But that freedom in action selection, that is also guided and constraint. Okay, now we look into the next topic of this lecture, decision making without step-by-step instructions. Yeah, this is very interesting actually. See, if you look at traditional programs which we have been like writing for decades, so in traditional programs, we have to give the recipe. Okay, this problem needs to be solved step by step. First we design the algorithm, then we convert that algorithm into a program. So step by step execution plan instruction we have to give. Okay, to accomplish this goal, this is the step one, step two, step three. So that is a traditional programming. The problem is that the sequence is pre-written and hence it is very rigid. Traditional softwares are very rigid. They cannot handle the complexity of the modern world. They cannot handle ambiguities, uncertainty. But if we talk about autonomous agents, here no need to write any logic. They will constantly, consistently, they will assess, then they will decide what to do. They will act, they will reassess, and they will keep on continuing it. The key characteristics is that the agent selects the steps dynamically. So no pre-written logic. It is very flexible. Agents can adapt because now the recipe is being invented by the agent itself. Because agent know this is the goal that needs to be achieved, and agent knows that right now I am at this point. I am here. I have to go here. So the journey will be decided by the agent. And in the journey, if agent sees that oh very big obstacle is there, then it will reassess its path. It will change the path. So like that, it will keep on updating its path and it will take you towards the end goal. So that is the dynamic nature of the autonomous agents. And this is a very big thing actually, because of that, AI agents can handle the complexity of the modern environment. They support flexible workflows, adaptive execution, and context sensitive behavior. This is very interesting because traditional programs they are rigid. No matter what the context is, they will behave in a similar manner. But autonomous agents, they support context sensitive behavior. They adapt their execution based on the context. So that is the idea. So the power of agents, if we talk about, it lies in their ability to adapt to changing environments, unlike static programs. So this is a very big thing. So we are talking about the fundamental shift from fixed sequences to dynamic execution. So dynamic execution is something which is the main, the key component or the key ability of autonomous agents. Okay, now we'll look into the next topic of this lecture, that is acting under uncertainty. So see, we know that the real world wherein we live, it is subjected to uncertainty. Uncertainty is something which is very common. We live in a very uncertain world. We don't know what might happen next. And the best example of it is like COVID-19. Like because of COVID-19, just imagine the machine learning models trained before COVID-19 and after COVID-19. All the trends, they got reset. COVID-19 was a reset. Like the trends pre-COVID-19 and the trends, the patterns after COVID-19 were completely different. So because of this COVID-19, many of the machine learning models, vision models, they became failed. Because after COVID-19, those models they started giving wrong answers because the trend changed. And that is what we are talking about, handling uncertainty, because the world is very uncertain. And when we talk about uncertainty, I'm talking about information is incomplete. When we train the model, we train it on a subset of reality because the reality can be infinite. We cannot consider each and every training sample. We have to take a subset of it, sample. Information is incomplete. Inputs may be noisy and outcomes are unpredictable because of that, because of we are not capturing all the possible patterns, and because of the noise, the training we did, the models they got trained, now we are not 100% sure that okay every time it will give the correct answer. There might be scenarios wherein you pass a pattern which the model has never seen before, there it will fail. So outcomes, and hence we say that outcomes are unpredictable, means we say that outcome can be correct also, wrong also. It can give wrong outcomes also. That is possible. That is the uncertainty. Now, the good thing about agents is that agents can strategize and adapt. That is the very big thing about agents. Now, we know that, okay, the knowledge is partial, because we cannot capture the real knowledge can be infinite. All the possible scenarios we may not capture. So the good thing about agents is that they can make some smart decisions with, even with partial knowledge, because here we are not explicitly training it, we are not teaching it the patterns. So here, like the large language model, the concept is very different. So it can make decisions even with partial knowledge. It can handle ambiguity. Even noise is there in the data, it can handle it. And it can revise plans when assumptions fail. So that is the very big thing. So partial knowledge is subject to assumptions, because we have to make assumptions. And the good thing about agent structure, or the agent architecture, the agent framework, is that agent will start with some assumptions, and based on that some outcome it will assess it, it will reflect on the outcomes, and it will understand, oh, this assumption is wrong, because the outcome is like very wrong. So it can reiterate, or it can consider next assumption. Like that, it can hit and try. And once it gets an assumption which is giving a decent answer, decent response, it can stick with that. So that is, we call it as adaptation. So it can revise the strategy, it can adapt. And this is something which makes agents so powerful, that in the world where we live in, wherein everything is so uncertain, we cannot just train the model once and use it forever. After a point of time, those models can become obsolete. So here agents plays the role. So if we look at an example, the same thing, like agent will try an action, and it sees that that action failed. It will retry with an alternative, and accelerate if the confidence is low. So it will retry, and it will assess the outcome, and based on that, it will perform some actions, and it can keep on doing it. So we call it the learning cycle. So the definition of AI agent, it is it that self only. AI agent, it is empowered with this learning cycle, wherein it can perceive the environment, it can plan, it can act, it can reflect, then it can adapt, then once again it can perceive, and it can keep on doing it. And AI agent is aligned with a goal, it is doing it to achieve a goal. So the moral of the story is that uncertainty is not a bug, it is not something like we can avoid. Uncertainty we cannot avoid, it is inevitable, we have to consider it. So it is the default condition, and we have to handle uncertainty. And interestingly, AI agents, autonomous agents, they can very smartly handle uncertainty. That's the beauty of it. Okay, now we'll talk about the next topic of this lecture, that is goal driven behavior. Now see, earlier systems, they were like response oriented. Okay, for input, we had response, and action was performed. So no goals, because earlier traditional systems, na, they what they do did, they just executed the instructions. They never knew what the end goal is. We just feed it the instructions, and they just execute the instructions. But now the modern AI systems, the AI agents, they're goal oriented. So we and the goal is being decided by the humans. So goals, they define success, they guide decisions, and they constrain behavior. Because see, every agent is aligned towards achieving a goal, and that goal can keep on changing also with time. Like once a goal is achieved, then it can eye for a next goal. So the goal is the one which gives the direction to the agent, AI agent. Goal will tell the AI agent whether it is on the right track. Goals define success. Goal will guide the decisions. Like whatever the decisions AI is taking, agents are taking, whether it's correct or not, goal will decide that. Goal will guide the decisions, and goal will constrain the behavior, because we know that this goal needs to be achieved. Then if agent is drifting away from its goal, then we will like on its own, it will like it will change its path. So goal will constrain the behavior of the agent. So with goals, the system behaves intentionally. So we call it intentional behavior. Intentional behavior means intention is there. A goal is working with an intention, an objective to achieve. And the types of goal, if we talk about, the goal can be explicit. Explicit goal means a direct goal which can be measured. Like, for example, resolve support ticket. It's a direct goal. We can measure it. Like how we can measure it? If the support ticket is resolved, then we say that the goal has been accomplished, mission accomplished. The goal can be implicit. What is implicit? Implicit goal means it is like indirect, means it is like an underlying principle. This here implicit goal example is maximizing user satisfaction. Now we cannot measure it. So the one very important thing about that, if you want to differentiate between an explicit goal and implicit goal, if you can measure the outcome, then it is explicit. And if you cannot measure the outcome, then it is implicit. Because if give a goal like maximize user satisfaction, now maximize is like something, it can go up to infinity. Like there is no limit, no upper limit. We can keep on maximizing the user satisfaction. So we cannot measure it. So it's implicit goal. And goals can be hierarchical, wherein like hierarchies will be there. Okay, phase one, phase two, phase three. So structure of primary and secondary objectives. So the idea is that goals transform systems from passive responders to active decision makers. So the goal-driven behavior of AI agents, autonomous agents, makes them very powerful. Okay, now we'll look into the next topic of this lecture, that is interaction with environments. So if we talk about agents environment, so the autonomous agents, AI agents, they don't work in isolation, rather they interact with the environment. So this is the agent, for example. Now this agent, it can interact with the data sources, it can interact with the APIs, it can interact with some tools, it can interact with the users, it can interact with other agents, and it can interact with physical or digital systems. So that is the agent environment. And agent loop, so we have been seeing it from the beginning of this lecture: perception, then decision, then action, then observe the effect and adjust behavior. And whatever action is performed, it will affect the environment. And once the environment is affected, so some things will change and we will perceive it. So this loop, this is the agent loop. So this feedback loop is very essential for autonomy. Yeah, so this is clear actually. Okay, now we'll look into the next topic of this lecture, that is interaction with humans versus interaction with systems. So with the like if we talk about human interaction, like agents, AI agents, autonomous agents can interact with human. And the good thing is that since AI agents, they understand natural language, the interaction can be in the form of natural language. Emotional context will be taken care of. AI agents will understand your mood. Based on that, the responses will be in such a way that AI agents, they can understand ambiguous instructions. It makes them very powerful. And subjective goals they can understand. That's very big thing, because until now the software industry is full about like very specific objective goals. Like you have to specify each and everything, but now you can be very vague that okay, uh, just order me some food. I can give goal like that, and AI agents can handle that. And how they will handle that? Okay, they got to know that you are hungry, you want some food, then they will start the conversation, they will start asking you some questions so that they can reach the goal. Because the goal is to order food. Now AI agents are totally unaware what food to order, so they will go in that direction. They will give you some recommendations. They will ask you what mood, like you want to eat some Italian cuisine or Chinese cuisine or Indian cuisine, like that it will do. So agents, so agents, like when agents are interacting with human, they interpret intent, they ask clarifying questions, and they communicate uncertainty. And agents can also interact with the system. Now, with the system interaction, AI agents, like we saw earlier, it can interact with APIs, it can interact with databases, it can interact with services, it can interact with the logs. So agents must follow protocols. This is very interesting because see, for human interaction, it is natural language, but for interacting with a system like APIs, it has a format. Like REST APIs, if you take it, it has a certain protocol. So database you want to interact, you have to interact it using the SQL language or some query, database queries you have to write. So, and the good thing is that AI agent is smart enough. They have to follow protocol, they can follow protocol. When interacting with the system, agents must handle failures and they should validate the outputs. So the key insight is that agent must speak both human language and machine language fluently. That's the very big thing. So autonomous agents, AI agents, they should have the capability of speaking both human language and machine language. Okay, now we will discuss multi-step reasoning and execution. So see, if we talk about single response systems, so the idea is that, okay, input is there, one step execution and output we will get. So the single response we got. So the limited scope, one of action. But if we talk about agents are like dynamic and adaptive in that sense that let us suppose it want to accomplish a task. First, it will break down the task. Then it will figure out the plan of action, sequence of actions. Then it will perform some actions and then update the progress. And then based on the, it will reflect the outcomes. It will adjust the plans mid execution, and then it will just keep on executing and monitoring, and it will keep on tracking the progress. So this loop we have been discussing for a long. But the good thing is that this task breakdown and multi-step. So uh, and hence we call it like multi-step reasoning and execution. So the idea is that to accomplish a goal, to accomplish a task, it can make an action plan consisting of many actions. So that is called as multi-step execution and multi-step reasoning. So reasoning is been done in multiple steps. Like first, based on the initial input, it is deciding, and then some task it is performing. Then based on the outcome of that, it is reflecting and it is adapting the strategy. So multi-step reasoning is happening, and multi-step execution, like to perform a small task, it can perform many actions. So multi-step reasoning and multi-step execution. If we look at an example, let us suppose we want to prepare a market analysis report. Like we want to analyze a market and we want to prepare a market analysis report. So the idea is that first, definitely we start with data collection, then we'll pre-process the data, then we'll do the analysis. That is what we do. Then we summarize our findings, key insights and all that. Then we will format, we will prepare a report, then we'll review it. And the good thing is that this entire life cycle agents can manage, and not in one step, but multi-step reasoning and multi-step execution. So I'll give you an insight. For data collection itself, agent can perform multi-step reasoning and multi-step executions. Then once the data is collected, then for data cleaning, agents can perform multi-step reasoning and multi-step execution. Multi-step reasoning would be like, okay, this is the chunk of data wherein we can break it into separate phases. Like for CSV data, a different strategy will be there. For PDF files, different strategy will be there, like that. Like that, every step we can do multiple multi-step reasoning and multi-step execution. That's the idea. Okay, independence versus supervision. Okay, so the idea is that we can have fully independent agents. Now, as the name suggests, fully independent agents, they can operate continuously, minimal human intervention, and suitable for low risk tasks. So for low risk tasks, you can like eliminate guardrails, and you can like let the agent operate with minimal human intervention. That's the fully independent agents. Supervised agents are one wherein human will always be there in the loop. it will be having some strict guardrails, approval checkpoints, and escalation paths will be there. Escalation path means if agent is going out of track, like if the alignment problem is there, humans will be notified. Humans will come into the picture. And most real world agents, they are autonomous but supervised. So it's a balance. So balance the real world agents. So there is a balance of efficiency, there is a balance of safety, and there is a balance of trust. So we cannot make agents fully independent also, and we cannot impose very strict supervision also. We should give certain sort of independence, and we should give certain sort of supervision. And that is, we call it like the balanced approach. And with the balanced approach, we will be able to achieve efficiency, safety, and trust. Common misconceptions about agents. So this is very interesting. So there are many myths and misconceptions. Like we started this lecture with these misconceptions itself. Like there are misconceptions that agents are just chatbots. Agents replace human entirely. Agents don't need oversight. Agents always know what to do. But this is wrong. The reality is that agents are decision systems wherein agents can take decisions on their own. They can act on their own, but human supervision will be there. Human intervention will always be there. So agents can never like agents is not about replacing humans, but it's about augmenting human capability. And agents, they do operate with constraints. Guardrails are there, constraints are there, monitoring is there, human supervision is there. So finally we completed this lecture, and in this lecture, like, we got a very good understanding about what are autonomous agents, and you got to know that okay, autonomy is all about decision making and freedom in deciding the action plan, but it's not about total independence from human intervention, or no limitations, no guardrails and all that. It's not like that. So the meaning of true autonomy you understood, and we saw that agents are goal driven. Goal plays a very important role. Goal, because of the goals, agents have intentional behavior. So I hope you got a very good understanding of the concepts which we discussed in this lecture. So do subscribe to our YouTube channel ScaleUp University for more such interesting lectures and courses. Thanks for watching. Thanks for your time.